So this is question number 1.6, and chapter is electric charges and fields, and we are going to solve this question. So first of all, read the question. What the question says: point charges QA is equal to 2 microcoulomb, QB is equal to minus 5 microcoulomb, QC is equal to 2 microcoulomb, and QD is equal to minus 5 microcoulomb are located at the corner of the squares A, B, C, D of sides 10 centimeter. What is the force on charge of 1 microcoulomb placed at the center of the square? So what the question says is a key. There is a square. Let me first make the square. We have QA here, then QB, then QC, and then QD, right? So after that, in the middle of this square, in the center of this square, I have 1 microcoulomb of charge, right? So now, and the side of this square is 10 centimeter, or you can say 0.1 meter. Okay. Now what we have given that QA is equal to 2 microcoulomb, means 2 into 10 to the power minus 6 coulomb. QB is equal to minus 5 microcoulomb, means 10 to the power 5 into 10 to the power minus 6 coulomb, and QC is equal to 2 microcoulomb, means 2 into 10 to the power minus 6 coulomb, and QD is equal to minus 5 into 10 to the power minus 6 coulomb, right? So these are the things that are given. The side of the square, let's assume A, is 10 centimeter or 0.1 meter. Okay. Now let's see that what this is saying is, first of all, let's determine the direction in which the force is acting, right? So first of all, at QA, what is the value of QA is 2 microcoulomb, right? What is the value of QB is minus 5 microcoulomb. Value of QC is 2 microcoulomb, and value of QD is minus 5 microcoulomb, right? So when you will see that you will find that here from the force that is applied on 1 microcoulomb charge from QD is attraction force, because it is working on positive and negative charge. Like 1 microcoulomb is positive, and 1 microcoulomb is positive, and QD is equal to minus 5 microcoulomb, that is negative. So the force that is working here is an attraction force, right? So the angle and the direction of this force is in this side. For force, let's say force on let's assume this charge is QO. So force on O due to D is in this side, right? Similarly, because this side also attraction force is working, minus 5 microcoulomb and Q naught. So force this side is also going to be if force on O due to B is in this direction, right? Now for QA, the force acting because of QA on Q naught is in opposite direction, because both charges are positive. This and this is a positive charge, right? So that it will be a repulsive force. This means the force is acting in this side. And similarly for this charge, similarly for this QC and Q naught, the force that is working is in this direction, right? Because they both are positive. Now what you will going to see that let's determine the magnitude of this forces. This force we can name it as force on O due to C, and this force we can name as force on O due to A, right? So first of all, let's calculate the force on O due to D. So the force on O due to D is K Q O Q D by R square, means the diagonal by 2, and that is going to be let we can say that diagonal is diagonal, what is the diagonal of the square is 10 root 2, a root 2. Since we have a square of this side a, then the diagonal is what we can get a root 2, right? So here 10 root 2, and it is divided by 2 because we only know want to get this length. So 10 root 2, 10 root 2 divided by 2, or we can write it as 5 root 2, 5 root 2, right? Got it? And now for magnitude, this is the magnitude of FOD. Now magnitude of F OB, let's calculate magnitude of FOB. So force on O due to B, so Q naught and QB by F root 2, that is the direction between these two charges, right? Now the force magnitude of force on O due to A is going to be K QO QA by 5 root 2, and force on O due to B is going to be K Q naught QB by 5 root 2, right? And now let's put the values of all the charges, and then we are going to get K Q naught is 1 microcoulomb, we are going to write it at last, microcoulomb, into QD is 5 microcoulomb. We know the direction, that's why I am not writing that we are writing magnitude, the direction we know. So I am only writing this magnitude, right? So microcoulomb into microcoulomb, the 10 to the minus 6 and 10 to the minus 6 of both is going to be 10 to the minus 12 by 5 root 2. And for FOV, it is going to be K 1 for Q naught, QB is minus 5 microcoulomb, and as I have said earlier, direction I have taken, I am only calculating magnitude. So 5 into 10 to the power minus 12, the 12 is the micro of this Q naught, and micro of this 5, that is 10 to the power minus 6, and 10 to the power minus 6 multiplied is equal to 10 to the power minus 12, right? Got it? So 5 root 2 is the distance between them, and this is going to be a square, sorry, this is going to be a square, this is going to be a square, this is going to be a square, my bad, this is going to be a square, and this is going to be square. Okay, this is it. And now what the FOA, magnitude of FOA is going to be 1 into QA 2 into 10 to the power minus 12 by 5 root 2 square, and FOB is equal to K 1 and 2 into 10 to the power minus 12 by 5 root 2 ka square. And now you can see that the magnitude of FOB magnitude, this and this magnitude is same, and this and this magnitude is same, right? So we can write by a side mi symmetry, by symmetry we can say, and from equation 1 2 3 4, by symmetry and equation 1 and 2, we got FOD magnitude is equal to F OB magnitude and FOD plus minus FOB is equal to 0, and by symmetry and equation 1 and 2 3 and 4, we got FOA magnitude and is equal to FOB magnitude is equal to FOA magnitude minus FOB magnitude is equal to 0. So we can see that net force acting on the charge 1 microcoulomb is 0, right? So what is the force acting on the 1 microcoulomb charge at the center is? That is 0. So this is the way you can write the answer in your exam, right? Okay.